Hello, everyone. So this is going to be a very quick presentation about setting up a continuous integration using Team City and Composed CI. The goal of the presentation is just to explore how one can set up continuous integration using a JetBrains Team City server and a set of tools that we've developed with Composed Systems, and those tools were developed by Steve Ball. I'm not going to be going into detail about the tools because Steve has done presentations on that aspect before. I'm going to cover a little bit of background on what continuous integration really has to do with the software release process. I'll talk a little bit about the architecture of a typical continuous integration build system. And then based on the continuous integration system that I got configured, I'm going to tell you a little bit about how to configure fetching of the source code from your source code control, how compiling in my setup works, how to compile the LabVIEW code, how to run the JKI VI Tester, how to build the application and get an executable out of it, and how to run static analysis and look at its output. So just a few words about me. My name is Maciej. I have some LabVIEW certifications. I'm a partner at Composed Systems. What am I about? I'm really into software development process and automating it. That's why continuous integration is something that I really enjoyed working on. Because if you can automate it, that it's fun. I have experience in multiple programming languages, and I have some examples that are .NET related here as well. And I have an affinity for programming in LabVIEW and G. So just to set the stage a little bit, I'm just going to go from an angle of what's the purpose of CI. So one of the major reasons why you would like to use continuous integration is it will enhance the quality of your code. It'll automatically check for dumb mistakes like committing broken code or missing items into your Git repository or whatever repository you use. It will automatically run your unit tests, so you don't have to remember to do that. It will automatically create a build artifact such as an executable or NI package or whatever the output of your software is, so you can then link it to your source code. And it can also automatically run static code analysis, which can be very useful if you want to see if you want to ensure that the quality of your code improves or degrades. It's also crucial for team development. It will ensure whether your merge code still works, and yeah, like I said, crucial for team development. So continuous integration and LabVIEW, what's special about it? Well, package management and the LabVIEW compiler, you can make a whole dissertation about package management and how to get your source code together on disk to get a LabVIEW project going. At Composed Systems, we often use Git submodules. So sometimes it's kind of tricky to get your LabVIEW source code to play nicely, especially if your submodule has embedded different paths than your output code expects. But this is where continuous integration can help you. If you download your software from scratch and recompile it, you know that it's good to go. LabVIEW and command line. Well, command line support in LabVIEW is a bit of an afterthought, but here I'd like to give a shout out for James McNally. We've used his tools in order to build upon them to be able to make LabVIEW sort of act nicely with command line, and that's part of the Composed CI. And the other challenge that you might face when you're using LabVIEW with continuous integration is the IDE likes to throw you a dialog box, you know, just to help you out. And that's very good when you're in front of the computer and doing stuff. But when you're trying to automate something, having that dialog pop up that tells you, hey, you had an error last time you ran LabVIEW, sometimes can be counterproductive. And the unit test frameworks. Now, one of the things that is very, LabVIEW has a lot of unit test frameworks. There are only a few that I know that do have code coverage. And that's why the example I'm going to have is not going to have code coverage, at least not for LabVIEW. But one of the good things about being able to set up continuous integration with a framework that has code coverage you could rope it into your results and know whether your test code coverage is going up, down, and what's your overall health of the project. Now, I just want to stop here and this diagram talk a little bit about the software release process under version control and where continuous integration comes in. Usually, the way we set it up one continuous integration branch. So that's usually the development branch. We would work on a feature, and then we would put that feature on the continuous integration branch. If the build fails because there's a bug, we fix it, and then those green dots here are basically continuous integration builds that go off a particular branch of our CI branch, and that's that way we know which commit is basically a good and which one's a dud and which one is a reasonable commit. And then we basically have the main production branch to which we merge or merge from in order to keep the CI branch up to date. But we also use these commits to promote them to production. So I'm going to show you how this can be viewed through some tooling in a sec. Just try and move to the next stage. The next example, so the example of the that I have prepared here is a kind of shows the architecture of a typical CI system. So the CI system that I am going to show you is Team City running on a CentOS. Now, it does have a Docker container running on top of it. And the reason I did it that way is you can download Team City as a Docker container. And the way it works, in a great simplification, there's a whole bunch of local files that you can have on your local system that are basically mirrored to your Docker container. They contain configuration results and logs. And the Docker container, if you don't want to go into setting up a web server, setting up your web application and doing all that fun stuff because you're a LabVIEW programmer, the Docker container is a very, very simple way to basically spin up and shut down your Team City. So in case the server has a bad day, if you've kept your local folders and files that contain the configuration, it's very easy to spin up a new Docker container, connect it to the appropriate folder, and your Team City is just going to work. So Team City is connected to a bitbucket cloud, and then it goes and builds stuff on agents. There's one agent that I have configured for LabVIEW and another one that does some building of Microsoft toolchain stuff. So without further ado, let's jump into my instance of Team City, and I'll show you how my LabVIEW build is configured and what you would need to do to get it set up. So here I have a Team City instance that has a couple of projects on it. We're going to jump in first into our composed lookup table project, which is a subcomponent that we use a lot in our projects. And I'm going to enter its configuration and just show you here the version control settings. So it's set up to work off a branch of lookup table that's on our bitbucket. And it literally has only 4 build steps. And those build steps are project recompile. So that step basically downloads the sources, recompiles the project, conducts the project open. So opens the project in order to see if there are any old broken VIs in it. And if there are none, it moves to the next stage where it runs the JKI VI tester and exports the tests of JKI VI Tester into an XML file, which is then parsed by Team City and runs the VI analyzer. So how does that look like after the build's completed? Go back to my project. And I can go to my build log, and those first 4 steps that I've mentioned have been executed here. And I see that my project was recompiled. Recompiled 39 VIs with no errors. The next thing it did, it opened the project. All VIs were valid. Next step was the running of the unit tests. which I'll show you the test results as well. And the last step that we have is the running of the VI analyzer. So that also has been run and went into the code inspection, which read the check style results. So 4 VIs have flagged some issues that you can read here, and then you can go into your source code and kind of look what were the offenses. And in terms of the unit test that I showed you before, you will also have all the unit tests pulled in, and you can browse them, see how long they took to execute, and whether they've been successful or not. So in a nutshell, that's how you can do it. If you have any questions, I'm going to switch over to the chat